We have our three formulas now. We have the future value of a single sum. We have the present value of a single sum. We have the future value of a uniform annuity. Now let's lead into our fourth formula, which is the present value of an annuity, and just the reciprocal again of what we just did. So this lecture, now we're going to go to the present value of a series of payments, present value of a uniform annuity, and the economic problems that we're going to look at is what we call capital recovery for fully amortized loans. And we'll show how loans for your cars, your trucks, or your homes are calculated. And it's basically under this heading of capital recovery. And we'll also talk about capital recovery for capital investments. Okay, this is a problem that's very similar to what we just covered. We're turning it around a little bit, and we're asking you, given a little bit of an investment flavor, how much would you be willing to pay for an annuity that paid you $100 at the end of each of the next 4 years, assuming that you can earn 10% on money in your savings account? Again, you see that we take that verbiage and we put it into a timeline where we represent the 4 periods across the top, and the $100 that we're putting in the bank that we're going to receive at the end of the next 4 years with an interest rate of 10%. The question is what is that annuity worth? What are you willing to pay for it so that you would be indifferent? Given that you have other uses of your money at 10%, you certainly don't want to invest in something that returns less than 10%, so what do you pay? And how do you figure that out? We're going to treat each cash flow separately and then add up the present value. So it's a similar concept as we did before. We're going to take the first cash flow, only this time, instead of going to the right, which was finding the future value, we're going to the present, and we're only going to discount it back 1 period. Of course, the second period, we discount it back 2 periods. The third, we're discounting it back 3 periods, and the fourth, we're going to bring it back 4th period, because this sum of money is going back 1, 2, 3, and then 4 periods. So we have to discount it back 4 periods. And these numbers, I'm just putting them here, but of course they're coming from these computations, which you can do using your calculators with exponents, or you can use your financial calculators to calculate those. And you may want to do that to make sure that you understand where those numbers are coming from. And then what we do is we take those 4 quantities, sum them up, and the answer is $316.99. What that means is that if you paid $316.99 and in return received the $100 annuity at the end of each of the next 4 years, you'd be getting back $400, you see. You would have an investment that returns 10% on your money. Given that's what you could do in your bank account, then you'd be indifferent on buying that investment or buying the annuity. Okay, calculating the present value using Excel. Again, we have the 4 periods, and each of those we're going to put in the present value. This first one's 10% for 1 period. The second one is for 2 periods. This one's for 3 periods, and this one's for 4 periods. So it's just like what we did before. Each one of those represents the present value of each of those quantities. We sum them up, and it gives us the same answer of $316.99, which we also received when we did it using our calculator. Again, for completeness, this is the formula for the present value of a series of payments. Again, I'm not going to ask you to repeat that on a test, but I want it in your notes